Welcome to G Fun Facts Online. Today, we are journeying into the deepest, darkest frontiers of the universe to discuss a discovery that has fundamentally shaken the foundations of astrophysics. We often think of the universe in terms of scales we can try to grasp: planets, stars, perhaps even galaxies. But astronomers have recently stumbled upon a structure so immense, so terrifiedly large, that it defies all previous scales of imagination. It is a leviathan that makes our entire Milky Way galaxy look like a mere speck of dust. It is called Porphyrion. Named after the king of the giants in Greek mythology who dared to wage war against the gods, Porphyrion is not a galaxy, nor is it a star cluster. It is a single, cohesive structure of energy and matter, a pair of bipolar jets blasting out from a distant supermassive black hole. These jets span an unfathomable 23 million light-years. To put that number into perspective, if you were to take our Milky Way galaxy, which is already 100,000 light-years across, and line up 140 of them side by side, they would just barely span the length of this colossal eruption. This is the largest structure of galactic origin ever discovered, and its existence has rewritten the history of cosmic evolution. The story of Porphyrion begins not with a look through a traditional glass telescope, but with a high-tech treasure hunt across the radio spectrum. The discovery was made using LOFAR, the Low-Frequency Array Telescope. Unlike the telescopes you might picture, which point giant mirrors at the stars, LOFAR is a revolutionary instrument consisting of a vast network of tens of thousands of small radio antennas spread across Europe, with a dense concentration in the Netherlands. These antennas operate in unison, effectively turning the entire continent into a single listening ear. They scan the sky for radio waves, the low-frequency whispers of the universe that are invisible to the human eye. These waves are the signatures of high-energy events, specifically the acceleration of electrons spiraling around magnetic fields, a process known as synchrotron radiation. An international team of astronomers, led by Martine Oy of Caltech and Leiden University, was combing through this LOFAR data to map the northern sky. They were hunting for giant radio galaxies, rare beasts where the jets ejected by a central black hole have punched through the halo of their host galaxy and expanded into the intergalactic medium. This search was the ultimate needle-in-a-haystack scenario. The team utilized a combination of advanced machine learning algorithms to scan images for jet-like patterns, alongside the eagle eyes of citizen scientists who manually inspected data to flag anomalies. Amidst thousands of candidates, one faint fuzzy line stood out. It was a streak of radio emission that seemed to go on forever. When the team realized what they were looking at, the scale was hard to comprehend. Follow-up observations with the giant meter-wave radio telescope in India and the W.M. Keck Observatory in Hawaii confirmed the distance and the host. The light from Porphyrion had traveled for 7.5 billion years to reach us. This means the structure existed when the universe was less than half its current age, making its sheer size even more baffling. To understand how such a monster is born, we have to look at the engine driving it. At the heart of Porphyrion lies a massive galaxy, roughly 10 times the mass of our Milky Way. And at the core of that galaxy sits a supermassive black hole, a gravitational singularity gluttonously feeding on infalling matter. Usually, when a black hole feeds, it forms an accretion disk, a swirling, superheated disk of gas and dust. As material spirals inward, magnetic fields twist and snap, launching a fraction of that particle soup outward at near-light speeds. These are the cosmic jets. Most jets sustain themselves for a few million years before fizzling out or being disrupted by the dense gas of their host galaxy. But Porphyrion is different. Its jets have remained stable and active for hundreds of millions of years, piercing through the galaxy, escaping its gravitational halo, and drilling into the deep void of intergalactic space. The structure consists of two opposing lobes of plasma shooting out from the black hole in opposite directions. Together, they span a linear distance of 7 megaparsecs, or 23 million light-years. The energy required to inflate such a structure is mind-boggling. The power output of the Porphyrion system is equivalent to the energy of trillions of suns. However, the most surprising revelation was the type of black hole powering it. Astronomers generally classify active black holes into two main modes. First, there is the jet mode, or radio mode. These are efficient engines that convert infalling matter directly into powerful jets and are usually associated with older, massive elliptical galaxies. Second, there is the radiative mode, or quasar mode. These are violently bright black holes that blast out radiation, meaning light and heat, rather than organized jets. These are common in the young universe. Porphyrion's black hole was found to be in radiative mode. Until now, conventional wisdom held that radiative mode black holes could not produce such stable, gigantic jets because the intense radiation would destabilize the accretion flow. Porphyrion proves this wrong. It shows that even the most violently radiating black holes in the early universe could launch jets that spanned the cosmos. This suggests that these giants might have been far more common in the ancient universe than we ever dared to dream. The true significance of Porphyrion, however, lies in its location. The universe is not a uniform scattering of galaxies. It is structured like a vast, three-dimensional spiderweb. This cosmic web consists of filaments of dark matter and gas that stretch across the universe, connecting clusters of galaxies. Between these filaments lie the cosmic voids, immense, empty regions of nothingness. Porphyrion is so large that it doesn't just sit inside a filament. It likely pierces through it and extends deep into the voids. As Martino A. explained, up until now, these giant jet systems appeared to be a phenomenon of the recent universe. But if distant jets like these can reach the scale of the cosmic web, then every place in the universe may have been affected by black hole activity at some point in cosmic time. This changes our entire perspective on galactic evolution. It means that black holes are not just local gardeners, pruning the star formation in their own galaxies. They are cosmic engineers. By injecting energy, heat, and magnetic fields into the intergalactic medium, structures like Porphyrion could have magnetized the universe. We know the cosmos is permeated by magnetic fields, but their origin has been a mystery. Porphyrion suggests that giant jets act as sowers, spreading magnetic fields and heavy elements synthesized in stars across millions of light-years, enriching the pristine gas of the voids. Before the discovery of Porphyrion, the title of largest radio galaxy belonged to Alcyonius, another giant discovered by the same team in 2022. Alcyonius spans about 16 million light-years. At the time, Alcyonius was considered a shocking anomaly. But Porphyrion dwarfs Alcyonius by a margin of 7 million light-years. To visualize this, consider that the distance to our neighbor, the Andromeda Galaxy, is 2.5 million light-years. Porphyrion is nearly 10 times longer than the distance between us and Andromeda. If Porphyrion were placed at the distance of the Andromeda Galaxy, its jets would cover a massive portion of our night sky, appearing larger than the full moon, glowing with the ghostly light of radio waves. One crucial factor in Porphyrion's growth is the epoch in which it lived. 7.5 billion years ago, the universe was physically smaller. The expansion of the universe means that in the past, the filaments of the cosmic web were closer together. This makes Porphyrion's feat even more impressive. It had to push against a denser, intergalactic medium. The fact that the jets remained straight and stable for 23 million light-years suggests an incredibly persistent engine and perhaps a protective magnetic sheath that kept the plasma focused, preventing it from fraying or dispersing into the surrounding gas. This discovery challenges our simulations of how galaxies evolve. Standard models suggest that jets deposit energy into their surroundings, stopping gas from cooling and collapsing to form new stars. If jets can reach as far as Porphyrions, they could be shutting down star formation in galaxies millions of light-years away from the host black hole. This implies a form of action at a distance, where a single black hole influences the fate of an entire corner of the universe. And this is just the beginning. With LOFAR continuing its survey and the upcoming Square Kilometre Array, which will be the largest radio telescope ever built, astronomers expect to find thousands more of these giants. We are entering a new golden age of radio astronomy. We are learning that the universe is more interconnected than we thought. Through the invisible threads of radio waves, we see that the chaotic, destructive power of a black hole can create structures of elegant, terrifying symmetry that span the voids between the stars. Porphyrion stands as a silent monument to this power, a 23 million light-year scar across the face of the deep, reminding us that in the cosmos, size is just a matter of time and energy, and even the voids are not safe from the reach of a giant. Thank you for listening to G Fun Facts Online, and stay tuned for more deep dives into the wonders of our universe.